Okay, question number 13. Right. Start the timer. Yeah. Diagram shows the arrangement of atoms in a particular crystal. Okay, shown here. Each atom is at the corner of a cube. So there is one atom here, there is one atom here, one atom here, and so on. Okay. The mass of each atom is 3.5 into 10 power minus 25 kg. Mass is given here. The density of the crystal is 9.2 into 10 power 3 kg per meter cube. Density is given. What is the shortest distance between the center of the two adjacent atoms? What is the distance over here? Okay. Now, what you need to know is, so many people make a mistake over here, saying that, see, if I construct a cube here, the cube will look like this over here, right? So, you will have a cube like this over here. At the center, there will be one, and it will be like this over here. It will be like this over here. So, you will be having this as a cube. And they will say, you have how many atoms? 1, 2, 3, 4, 5, 6, 7, and 8. There will be 8 atoms in one cube. So, should I take something like, the question is very easy, no? Density is equal to mass by volume. Should I take mass to be 8m? Definitely no. Why is it no? The reason is because if you visualize this one here, let me just give this, it takes some time for me to teach you this. Okay, if you visualize this, one atom is being shared by 8 adjacent cubes. Okay, one atom is being shared by 8 adjacent cubes. For example, if you want to show that, because he says there are several adjacent cubes over here, right? So if I have one atom over here, so if I draw a cube with this, so this is a square here, it's a square here. So this would be the cube here. This would be the cube here. You would have studied this in solid state, okay, or maybe in atoms in your chemistry also. So you have something like this over here. See, a part of the atom is being present over here, not fully. So therefore, 8 atoms occupy 8 corners of a cube. So 6, So 8 corners of a cube, and as a result of this, you see the contribution of one atom to this is only 1/8 of it. So since there are 8 vertices over here, 8 corners over here, 1, 2, 3, 4, 5, 6, 7, and there's an inner corner here, 8 corners like this. So therefore 1/8 multiplied by 8 is equal to 1 atom. So the total atomic contribution due to all these atoms in a cube is only 1 atom. Thus, you should consider only one mass. So therefore, now what is the mass over here? Mass is 3.5 into 10 to the power of minus 25 divided by volume. What is the volume here? If A is the length of each edge, this is A, this is A, X, Y, Z. There should be A cube over here. And density we already know. So A cube should now be equal to 3.5 into 10 to the power of minus 25 divided by 9.2 into 10 to the power of plus 3. When I do this, let me take my calculator and then find out what is the value here. The value is, where is this now? This value is 3.5 divided by 9.2. When I do this, I get this as 0.380. 0.038 multiplied by 10 to the power of, this is 3, this is minus 25, this should be minus 28 over here. In other words, I can now write this as 0.038. Shall I write 0.038? Yes, 0.038 into 10 to the power of minus 27. Why did I take 27? Because you know 27, this is A cube here. If I take the cube root of it, what do I get? A should be equal to 0.038 all to the power of 1 by 3 into 10 power minus 27 whole to the power of 1 by 3. So this is very easy for me to calculate, right? So because 3 9s are 27, I can easily get. So I need to just find out what is this value here. So once again, without calculator, can't do anything with this. Okay, so I have 0.038 to the power of 0.33333. What is 0.333? Because it's 1 by 3, right? So I can write like this, 0.3361. So answer should be 0.3361 multiplied by 10 to the power of minus 9. This should be, what do I do? I have in terms of one digit and as a decimal point. I'll write this as 3.36 into 10 to the power of minus 10. Now let us see the closest answer to this. 3.36, oh, this is 3.8, 3.4. Okay, I can now write this as 3.4 into 10 power minus 10, which is the closest answer. So C is the right answer. Okay.